This is the program to demonstrate the graph data structure. So here we are using a family tree to represent, to understand the graph data structure. So initially we are creating a class person in which we'll be having the details of the person. That is, we'll be having an ID of the person that will be unique, and the name and gender and age. So we are considering ID and name to be unique values. Okay, so this is the person class, and then we are creating a family tree class. Okay, so this family tree class will be having this graph tree as a property, and it is having these methods for adding a family member, for removing family member, for editing a family member, adding relation between two members, and then printing out the family tree. Okay, so initially for adding the family member, we are uh, giving the name parameters as name, gender, age, and ID. That is all these parameters of this person class. So first here we are adding this assert to check whether this ID is already present in the tree or not. If it is not there, then we'll be creating a person object of that particular details, and then we'll be adding it to the family tree. Okay, so this graph tree dot insert, and then we are giving this person as a parameter to this insert method. Okay, and then to remove any family member, we are passing the name as a parameter, and then if the name already exists in the tree in the graph, then we'll be removing that particular member from the family. And for editing as well, first we are checking whether that particular name is there in the graph of the family tree. If it is there, then we'll be editing that particular person with the new details of that with the new given details. This is for editing, and then this method is for adding relationship between two members. So here we have added an assert that we cannot have a relation with ourselves. So that is what the assert means name one and name two should be different. So only with this we can have the relation. Okay, when if this assert is true, then we'll be adding a relation between this name one and name two. Means these two persons will be adding the relation which we are getting here. And this print method is used for just printing that complete graph, the family tree. Okay, so this family tree is backed by this graph file. Okay, this graph class. So here we are having this all the methods to insert, to remove, to edit, and to add relation between the members of the family. Okay, so initially, first we are having this dictionaries, graph, person, and person ID. So whenever we are inserting a person, so for the dictionary person will be having the key as the name of the person. Okay, so with that particular, we'll be creating the key of that name, and then we are adding that person to that dictionary. And then for person ID, the key will be the ID of the person, and then same thing we are doing here. And then that particular ID we're adding to that graph, SAM graph. Okay, so this is how we will be inserting the person into that dictionary. And then to remove the person, we are using that ID. We'll be getting the name. From the name, we'll be extracting the ID of that particular person, and then we'll be removing that person from the person ID and the person and graph. All these three dictionaries will be removing that particular person with the help of this name and this IDs. After this, whenever we are removing any member from the family tree, we should remove all the relationships of that particular person with other family members. So that is what we are doing here. We are finding for any relationships of that particular person that is being removed, and then we are removing that relationships as well. So this is the remove method. And to edit method, we are getting that person object with the help of this name, the previous name which will be having, and then we are giving the new name, the new gender, and the new age to this person, and then we are removing that person with the old name from this dictionary, and then we are adding that same person with this new details with this new key, that is a new name key. We are adding that person to this dictionary. This is how we are editing the person. And now let's come to the adding relationship between two members. So initially we are getting the IDs of the two members, and then with the help of this IDs we can do this stuff. So first we are checking whether the relation which we are getting here is either siblings, married, or divorced. Okay, so if the relation is married, then we are checking whether that particular person is already married or not. That means this ID1 should not be married. If it is married, then we cannot marry him again with the means with the third person. So similar check we are doing for ID2 as well. Means that particular person should not be already married. Okay, so once this is satisfied, then we are adding that relation to that graph. We are creating that relation and then adding it to the graph for whatever it is, either siblings, married, or divorced. Okay, all these things will be added with this lines of code. And then here what we are doing is for siblings, if for example, if A and B are siblings and B is having another sibling C, so what we have to do is A and C are also siblings. To add that thing, we are using we are doing this particular code specifically for siblings. So if like ID1 is already having like any siblings other than ID2, we'll be adding that particular sibling, we'll be linking that particular sibling to ID2 as well. Okay, so that thing is being done here. And then if the relation is children, so first we are checking if there is like okay, let's go to parent first. So whenever if the relation is parent, we are calling this same method with the names as interchange swapped, and then the relation will be children. Okay, so whenever the relation is children, and if that particular relation is not there in the graph, then we'll be adding it, and then we'll be adding that particular ID1. So this ID1 linking, we are linking that ID1 children to ID2. And similarly, if like for example A is a child of B, then B is the parent of A. So that those two links we have to do from like vice versa. Okay, so that is we are doing here. We are adding a children, and that we are adding the parent to the particular child. That is being done here, and then this is used for printing all that the complete family tree graph. Okay, so now let's execute this class. Here actually we are adding all the family members of that given in the from the given document. All these 13 family members are added, and then we are creating this families, family 1, family 2, family 3, all these things till 8 families we are creating, and then we are printing out all the values, the other complete graph. Okay, so here like we are adding first for adding family members, we are giving the name, the gender, the age, and then ID of that particular member, and then adding it to the tree. And then for adding relations, we are using this like name 1 and name 2, and then the relation. So these two members are married. So and then this member is a child of this Patrick, and then this is a child of Hannah as well. So this is the father and this is the mother. So we are linking this particular child to with to this both of the like father as well as mother. And then here we are making this Henley and Catherine as siblings. So similar things we are doing to all the family members, and then we are adding the relations. Now let's execute the program and see the output. So here we got the output of this particular program. So here how we are printing it out is this first we'll be printing out the relation. Okay, here relation plus of the particular person which we are having is then this list of that particular relation. Like for married of Patrick Earnshaw is Hannah Earnshaw. Okay, and then children of this particular user is these two, Catherine and Henley. So this is how we are printing all the relations of all the users in the tree. Thank you.